Welcome back. Today we're going to be talking about the conservation of energy. This topic is a little different than you might think. A lot of students assume I'm going to be lecturing them about conserving energy by turning off the light switches or turning off desktop computers, which you should be doing. But I won't be focusing on that today. Today we're going to be focusing on the law of conservation of energy and the idea of energy transformation. The law of conservation of energy states energy cannot be created or destroyed. However, it can be converted between forms. In the picture, we show a cannon being fired. This is chemical energy, as it needs to be lit on fire. When the ammo reaches the top of the arc, some of that energy is transferred. It now has less kinetic energy and more potential energy. Finally, as it approaches the ground, it has a great amount of kinetic and not much potential. In the last section, we talked about the idea that as potential energy decreases, energy will increase. However, the total energy remains constant. This is transferring energy into different forms. We can transfer lots of different types of energy. For instance, when you eat, the chemical energy in the bonds of your food can be broken down and changed into mechanical energy. Radiant energy can be made into chemical energy through photosynthesis. The chemical energy in gasoline can be converted to give your car movement. And lastly, electrical energy from your toaster can transfer to create heat to toast your toast. Mechanical energy transformations. So mechanical energy is the sum of kinetic energy and potential energy in a system. So bicycles, roller coasters, and swings can often be described in terms of mechanical energy. We will discuss this in a great bit in our labs. Think about the swing or swinging on a swing. Every time the swing moves, the ropes or chains rub on their hooks and the air pushes the rider. The temperature of the hooks and the air increases slightly. Mechanical energy is not destroyed. Instead, friction and air resistance transform mechanical energy into thermal energy. Next, if the swing rider wants to continue to swing, they must apply energy to the swing. We do this by pumping our legs. Now we are converting chemical energy from the food we ate into additional mechanical energy. There are many other types of energy transformation as well. Hair dryers and irons can convert electrical energy into thermal energy. Televisions transform electrical energy into radiant energy and sound energy. Light bulbs transfer electrical energy to radiant energy. The picture to the right gives you a few more examples. Again, electrical energy can be converted into thermal, light, heat, or sound energy. There are many examples of chemical energy being transformed. The most popular example is probably when our bodies eat food and convert that chemical energy into from the food and use it to breathe, to pump blood, move, or even to think. However, there are many other examples as well. Think about cars. Cars run on gasoline, which is a chemical energy, and when the bonds break, in the gasoline, the chemical energy is transformed into thermal energy and then into mechanical energy as the car moves. This is why your engine gets hot when your car is running. In our pictures, we see a rocket flying. This is the same example as the car ultimately. The bonds are broken in the fuel and the rocket is propelled. The other picture is of a tree going through photosynthesis, meaning the tree is converting the radiant energy into chemical energy to store as food for the tree. Sometimes it's hard to recognize energy transformations because we can't always see or hear them, but they do always exist. Now that we understand energy, we need to understand what power is. You probably get enough energy every day to jump to the top of the Willis Tower, but you can't. And the reason why is because we can't convert the energy that quickly. Power is the rate at which energy is converted. The equation for power is power measured in watts is equal to energy, which is measured in joules, divided by the time, which is measured in seconds. A typical person can develop a power of about 500 watts for one single jump. This would result in a jump that is less than 1 meter high. So how does energy conversions relate to the food we eat? Energy from the food is usually measured in calories. 1 calorie is equal to about 4,000 joules. Every gram of fat is about 9 calories, or 4,000 joules of energy. Carbohydrates and protein is about 5 calories, or 2,000 joules of energy per gram. Now, it should be noted that the calories need for different activities would depend on your weight, your body type, and your degree of physical activity. Therefore, the chart to the right is just an estimation. That's all for today. Thanks for joining us. Again, if you need help, please rewatch the video or refer to your textbook, and we'll see you next time.